Hi, I'm just going to take you through some of my projects. Start with some projects from this year. Actually, start with this one. This is my favorite one. This is a 3D model of a protein, and I'll tell you the story of how this interactive model came about to be. You can zoom in, you can check the model in great detail. You can see the chains where they start, where they end. That there are two chains in this model. The color changes based on the residue, and I'll just show you how this came into being. So I had to make an illustration. I was given a reference picture. I opened up my 3D software, 3D Studio Max, and I tried to replicate it visually. It looked like confetti, a lot of spirals connected through with arrows, and some phosphate clusters. So I started making it, but then it was nowhere close to what an actual structure looks like. So people who are familiar with the structure, for them, they can see the difference. And for an ordinary novice, it might look the same. Hey, this is as similar as this. Both look like confetti, but there's a very big difference in the details. So what I did was I downloaded the software. It's provided by the University of California, San Francisco, UCSF. So I got this software. I loaded a model which the lecturer pointed me to, and so I got a converter, got the model which the professor pointed me to, loaded it into this protein modeling software. It also allowed me to color it, and you can see if I colored it based on chains, there would be basically two colors, and you can see one of the chains is highlighted there. But to make it visually attractive, there was an option of residue, and I saw a lot of these protein models who are actually colored by the change in the residues. So I colored it, and that's how it came to be. Once I got the 3D model out of the software, I could take it into a 3D software, and I could make it interactive like I showed it you earlier, and we are also planning to take it into the VR world where you can actually see it in 3D. So that was one of the projects. This is another one. I made about 47 Chinese character animations. Some of them actually the strokes had to be fixed, like this one. This last bottom stroke comes last. So I made about 47 of these for a larger interactive Learn Chinese project, which Nicole is working on. But yeah, the trick here was to actually isolate the stroke. So when you make one stroke, because it's a flat 2D character, you have to isolate the various strokes as layers. So instead of isolating them, I came across a neat masking trick. So I just found a cool hack that worked for me. This is from last year, a pretty decent project, a very useful one from the university's point of view. So it was made for Charlotte Brownlow and Amelia Dow. So they had this request where we needed to make something which is useful for students with disabilities, and especially if they have anxiety about coming to campus, they should know beforehand where things are, and they should have a good visual idea of it. This map itself has got overlaid markers. We tried with a few things like Google Maps, but we wanted it to look really, really nice. So Zoe made this nice designer look map, and we really wanted to use this, so we settled with a JavaScript library called Leaflet. It took a lot of time, and it was worth experimenting with it, because another project which I will show you in a few minutes actually benefited from all the things that we learned from this project. So what do we have here? We can actually see the pathways and lifts. You can see all of these entry points. You can see which buildings have lifts, and the details in G-Block will actually mention how one can get into G-Block, although there's no lift here. It shows how you can use a lift here or here. It shows where the disability toilets are, and we have, I think, 26 disability toilets on this side of campus, maybe 24. So yeah, as a part of the project, I went into every single block, every single level before I marked it. There were other campus maps available, but I wasn't sure. And the entire team actually went and checked out various entry points, various toilets. So this was like an entire team effort. There was video being shot. The photographers were taking photographs, and I'll show you. Like for example, you can go into G block and you can open it. So you can see what all is in G block. So you get a very good visual idea. The photographers have done a fantastic job here. And then you can see what all is there in G block, how to access the higher levels of G block. Does it have disability toilets? No. Which are the nearest disability toilets? What's on level 1, level 2, level 3? And these are things, again, I went and personally checked just to make sure that it's right, at least at the time of publishing. Another thing after feedback was the students said they would like to know beforehand what the approach into the campus looks like. So I'll just zoom out a bit. We added 3 videos. One from Ring Road West, one from Ring Road East, and one from the community drive. And you can access these videos, and what the videos do is it takes you through a walk from that point. It even points to various blocks. So it says that's a B block, and if you go a bit further, it says, okay, that's S block, and so on and so forth. Yeah. So all of the walks into the campus, they end up near R block. So you can access the campus from here, it walks through, then from here it walks into the R block, and from here it comes all the way to the R block. It gives you a very good idea of the campus. And it has a lot of information currently available only for the Toowoomba campus. And there are some videos, let's say for example in R block, it actually shows you a video as well. Sorry, that was the video, yeah. So it takes you inside our block, and I'll just quickly forward it so you can see. So you get a very good idea of what it looks like. So that was the campus map. A beneficiary of that product was this one. We had already done the cultural audit, but the maps we had used, there were some issues with it, and the client wasn't really happy with the map. So we used the same technology, so to speak. We used Leaflet, and you can see it's Leaflet, and we used OpenStreetMap because we just needed one street really, and it was an open course. Google licensing is really big, and there are some fine print in Google Maps licensing policy. But anyway, so yeah, this was another educational resource, if you like to call it. And this has several audios. It's got several audio clips. So it has got these various locations about which the lecturers were talking, and they mentioned how the Maple Leaf weren't very, very Australian. They gave a European look, a Canadian look, and so on. So it was for a course. This one was a really nice project. I really like it. The client, the lecturer gave us some material about the logistics industry, about how various trucks can attach only certain types of trailers, and if you add a trailer, it can only go at a particular speed, and how various trucks have a different capacity. They require drivers with a different license, and so on and so forth. So we tried to put all of those ideas into the game. Zoe did a great job of the graphics. And when I came, the graphics was sitting. It was probably the most challenging job because it wasn't so much the physics and math involved, but it was trying to programming it. So here, if you can see, if I start from this screen, you can see you can go to these 4 destinations. The load you have to pick up is 0.03 tons, 3 tons, 2 tons, 5 tons, randomly generated loads, randomly generated destinations. And it says, yep, it gives you a green tick. This truck has a capacity of 5.6 tons, so it will work. But if I say I want to go to Grafton, it says consider using a smaller vehicle instead to save costs. So because I'm using a very small, I have a very small load. And actually, I put that intentionally. The first destination has a small load because it gives the students an option of riding a motorcycle. Also, if you try to add a trailer, it says you can't add a trailer to a motorcycle. And all of these combinations are there. So the learning starts from this menu itself. There's a lot of learning that happens. For example, if you take a big one, a big truck, and you try to put a small trailer, it says you can't add a small trailer. And if you try to drive, it throws you out of the game. And if you put a trailer, it says, hey, the trailer will slow you down and cost extra fuel, because in this case, you don't need a trailer. So all of these options, they commence the students' learning straight away. So I don't need a trailer here. I'll just take a truck. And I can't add a small trailer to a truck. It will throw me out. So I'll just take a proper truck. Then I'll go and choose a driver. It says, hey, Bert doesn't have a license for the vehicle selected. Once again, if I try to actually start the game, it throws me out. So I can choose a driver, and then, for example, this guy is a thrill seeker, and your chances of getting a speeding fine and a breakdown are higher if you choose this driver. So I've tried to simulate those things. And I've also simulated time. For example, you'll see we will have the cost clicking over as the time progresses. So let's select this driver. Start. Now it says perform maintenance checks. I'll say yes. If I say no, then there's a decent chance of a breakdown. So that's also programmed. And you can see there's a total cost here involved. That cost comes from the driver cost, the fuel cost, and all of this is simulated. I've assumed 1 second to be 1 minute. Now, there's a warning that I'm going to get a speeding fine, and I might even get one. You might see a flash coming somewhere. This is the distance I have covered. I can move left, right, but that's about it. I can't hit any of the passing cars because this isn't a game. It simulates a lot of the things. I can turn the radio on and off, I believe. Yep. If I was to undertake 10 journeys, and that's a 60 zone, so that I've got randomly programmed 60 zones. If I undertake 10 journeys, then I can easily come up with a cost per ton per kilometer without actually taking a vehicle out of the yard and traveling to these destinations. So it's a great simulation, and there's a great learning exercise here about the various rules. So if you have finished about 2 hours of traveling time, it will tell you that, hey, you should be taking a rest for 10 minutes. And we are actually making another simulation. There's a petrol pump coming up. It says, hey, do you want to fuel up at this thing? And say, no, thanks, I'll pass. If I run down my fuel, it will actually charge me. It will affect me in terms of cost and time, because I'll have to order another vehicle to get fuel for me. So there's a lot of simulation here. And the new product we are doing for this one is tasking, where it goes to different destinations, drops some load, picks up some load for the return journey, and there it highlights the regulations. So use your brake, bring your car to a halt, and so on. So I can actually bring myself to a halt, and you can see if I actually wait for some time, my health will recover. You can see there's a health here, and you can see slowly, there you go, it's recovering bit by bit. So if I wait long enough, it should, you can see that my health is recovering. So there's a lot of simulation here. This was just something to try out for a virtual environment. I did this experiment last year, and this year when I created the protein model, the scripts that I had written for this came in handy. So I've got my protein model sitting inside a game engine, and this was just a fun thing that I made. But the idea was to try something for an immersive environment. This was for the video production team. The design and storyboard had already been done by Zoe. It basically was trying to give tips to people who come and record themselves against a green screen for various educational resources. So what works in front of a green screen? What doesn't work well? So there were various animations. Will this outfit work? No, please wear some clothes. And I came up with some dad jokes. So he came up with some dad jokes, and so on. There were people contributing to dad jokes. So all this kind of works. So the various outfits which people tend to wear, and what colors are really good and what are not good, and so on and so forth. So So if you wear black, it has to be a matte finish. If it's shiny, it causes problems with the light. So that was a small project there. This was a small, again, experiment in Unity to try out something interactive. It was a small challenge set by our supervisor. And again, what we learned here then gets applied to other things like the protein model. So for example, here, if, with my mouse moving, the character moves, and I could apply this to the protein model where if I move my mouse left and right, the protein model goes up and down. So I called this Play with Larry, and it was a small exercise, but yeah. And the whole thing is you then keep those scripts and you recycle them in another project. This was my first one. When I got scared of the game, Zoe gave me something very easy, and this is like the bread and butter. This is what I expected in a job like this. When you apply for a job with HTML, CSS, JavaScript, you expect to be doing these kind of things all the time. But of course, the role here is a lot more challenging. I'll show you some more HTML, CSS, which is really the standard bread and butter kind of stuff for this role. So these are the kind of things you'd make, help the designers. That's another, you take a design and convert it into HTML, CSS code. Pretty standard bread and butter stuff for this role. This was another game. So in this game, student services had this idea that a student should write the time. They should try and recollect a time when they failed in life, recollect a time when they actually succeeded in life, and then scrunch the note which has the failure and whack it. And so it was like whack your fails away. I don't know, it might work for some people. So like, what a mistake you have made? Oh, I forgot to eat breakfast before an exam. I don't know. What did you learn from it? Okay. Have a nice Hungry Jack's breakfast. So I can scrunch this note and then keep this note and play. And what happens is that I get those crunched notes and I have to whack them away. So that's what the game is called, whack or fail. And if I have a good hit rate, so there are 3 types of trophies at the end of it. So what happened in this case, the game evolves. So the client has some idea, and when I started making it, I realized, okay, so what is a win point for the client? What is a when do I win and when do I lose? So there were no ending points for the game, and what if I hit more? What if I hit less? So I came up with this scoring system, 3 out of 3, and for different types of fails and whacks, I get different scores. And you can see here there's a random speed with which the thing is coming, and it's actually coming a lot faster now. So yeah, that was one of those games. And these were just game assets for a tic-tac-toe game that the other developer Shane programmed. So I just made the graphics for it, and this was a simple VR project again that I was trying. I was just trying to play with 3D and trying to take a 3D model into Unity and then push it into a WebGL format so it can play inside a web environment. Again, things like these then come in handy for the protein model. And once you get them in this environment, you can always take them further into the VR world. This project was a really long one. The team had already worked on it. When I came, it was brought back to life like a true phoenix. So I started learning from scratch. I didn't know anything about surveying. I started familiarizing with my terms. I first broke down the entire project into 2 smaller projects. One was leveling and one was area calculation. So in area calculation, I broke it down further into using the equipment to take readings in a particular way. What are the requirements? Where you start with a known point, and then you apply the maths of trigonometry and area of a trapezium to actually use those readings to find what the area of 4 random points on the surface of Earth are. And the first part was leveling. So leveling, I started educating myself when I saw the storyboard. I did not know what the BS is BS and what is FS and what is IS. So I just sort of tried to teach myself. Now, I put what I learned, and I've not matched it yet with the USQ study desk, which I should. So I'm still waiting there for material from the study desk, and this can be matched perfectly. The reason why I repeated it was because you don't want to go and then open your PowerPoint and try and see, hey, what does this come from? So if you're making a nice small interactive resource, it's good to have the lookup help straight away. So that was a good thing there. Now what I was trying to do here, and having done interactive learning resources for 20 years, we follow one golden rule, which basically says, I hear, I forget, I see, I remember, I do, I understand. So I try to put everything, hear, see, do. So if you see equipment setup, I went and then sort of studied the equipment. Whatever I learned, I put it in this resource. I'm encouraging the teachers to build such video resources. This one is from YouTube. It basically shows how to set up a tripod and how to take a reading. Then I went around with Nabraj, and just a bit of background story here. I met a gentleman in one of my 10-day silent retreats in 2016, I think. He was from USQ, and I ran into him on my first day at USQ Toowoomba. He basically said if I needed help, I could come to him. And he was the research technologist in engineering department. So when this project came my way and I didn't know where to go, I went to him. And he introduced me to Luke. Luke introduced me to Nabraj Subedi here, whom Cindy calls as hide and seek champion of 2017. So Nabraj Subedi, I mean, fantastic guy. He took me around, actually showed me the entire process. I learned, and whatever I learned, I put here. So what I did was I made a resource for a student who knows nothing like me, who came from zero. And I had been teaching for 14 years, so I had a bit of that advantage of how to cater for the lowest common denominator in the classroom. Now the teachers here want to make it a bit more complicated than basic stuff that I've put here. And it's not a problem. You can make level 2, level 3 resources, but you don't overwhelm a student with content. You give them 50 PowerPoint presentations, they're sure to fail, you know. So this was a level 1 resource, I would say. And just wanted to do the entire thing. So I wanted to show them how things are done, and then they can practice it. So the level run demo, and again, this could probably be the second video. Here I've just explained in an animation how that works. So I've just explained in an animation how to take the readings, what is the sequence of the readings. And I've even simulated the dummy level. You have to focus this ring to get the crosshair, and this one you turn to get the readings marker. So there are 3 points in which you place your level, and these are their various readings. I've named them. And then I've shown the student how they are entered in the table and what to check for. And then I've given a sample reading. This actually is the same sample reading that I undertook with the PhD student. So Sarbeas, Nabraj, and Dileep there. What do we do next? There was a drama with the instrument. So the 2-peg test was requested. Again, I did not know what a 2-peg test was. This is purely, I went and looked on the net, taught myself, and I still have to check with the teacher if this is correct. So a 2-peg test basically says that if your instrument has an error, instead of shooting a horizontal line, if it is shooting at an angle, you are bound to get this error here, you see, between the 2 lines. And the error is greater depending on the distance. If you're close by, the error is smaller. So there is a 2-peg test where you take reading on this side, one reading on this side by placing the level exactly between 2 markers. Then you place it at 5 meters here, and then you take 2 readings and you apply a formula to calculate the error and to then apply the correction. And then I've simulated it here as well. So you can actually try to focus and get the S1 reading, enter it here, then go to the next one, take the S2 reading. So where does S1, S2 come from? That's S1, that's S2, that's S3, S4. That's the 2-peg test. You place a level here, place a level here. Take the readings, and then you apply a formula. And that's the collimation error. That's the formula that needs to be applied. There are some other bit exercises which really drive a point. And for example, here, a level always has to be situated between two markers. And a spirit level, when you do the fine adjustments, makes the bubble move in the direction of the towards the screw. If it's clockwise, then you can see that a clockwise towards the screw and anti-clockwise away from the screw. So this was done by Shane. A lot of work, as I said, had already been done by the team before there was an attempt to reselect it and I came in. Again, this one goes away. So, and this was another simulation where the marker is supposed to be in between the two staffs. So there was a bit of I understand type of exercises. And finally, the reading and calculation exercise. So this was to simulate the focus of the level. You take a reading, so that's 25, 1, 2, 3, 4, 5. And another 5. That's probably 2, 5, 5, 5. So that's 2, 5. Then you count these pointers 1, 2, 3, 4, 5. And then between these two, you again use these other two markers to get the reading that's there. So that's in between the two markers, 2, 5, 5, 5, and so on. And then you take the next reading, which is a foresight, and you enter the foresight reading here. So this table actually gives you hints where to enter readings, and then it tells you to calculate the sigma, the total of backsides, the total of foresights, calculate the total of the rise and fall, and match where the backside minus foresight is equal to the total of rise and fall. So it's a very simple thing, and I removed the intermediate side here because the basic concept of rise and fall has to sink in. And again, I agree with the teacher that is very simplistic from a professional surveyor's point of view, but from a person who has come from zero and is just about to learn or embark on a journey of learning surveying and engineering, it's a level 1 resource that should give them a foundation on which they can further their knowledge. So I think that's the last one that I had to show, and that's all from my projects. Thank you for your time. I'll end the recording here.